Right, so probability rule number 5 gives us an alternate way to find our conditional probability. So what we have is a formula for the probability of A given B. We're going to take the probability of A and B divided by the probability of B. So depending on whether we're being given a table of information and or probabilities, we may choose to use this formula and or go through the original problem. So order matters. Remember, the probability of A given B and probability of B given A are not the same, but we can also find our probability of B given A the same way. Take our probability of A and B and divide it by our probability of A. So basically we're dividing the probability of our and divided by the probability of whatever we're given. Then we also see an alternate rule for 5B. The first result we get by multiplying both sides of rule 5A by P of B. And then we multiply the alternate one here by P of A to get those other formulas. All right, so let's look back at another example. So find the probability that a person with less than a high school degree is married. First, we're going to use a table. All right, so thinking about what we're given that a person has less than a high school degree. Right, so less than a high school degree is 125. That's going to be our denominator. Right? And then our numerator would be that a person with less than a high school degree is married. Right? Well, that is going to be 70. So that's our numerator. That's the and portion. Right? They are married and have less than a high school degree. Right? We divide this out. We get 0.56 or 56%. All right, next we're asked to verify this using our formula. Right, so if we verify this using our formula, it's going to, let's do this way so that we can see our answer to the previous one. It's going to look pretty much the same, just with one tiny little bit of a difference here. Right, so what our difference is going to be is that we're going to have denominators if we're technically looking at these as probabilities. So that being said, our probability that someone is married and has less than a high school degree, if we were looking at total, that would be 70 out of 665. Our probability that a person just had less than a high school degree, well, that would have been 125 out of 665. Right. Then what's going to happen is whether we think about this as dividing fractions, we flip the second and we multiply, and then we cancel out, they have the same denominator. So this just simply results into 70 over 125, which we saw before, which gives us the same 0.56 or 56%. So it seems a little bit redundant in this example to work through it again, but this is just to show that this rule does work, because then we're going to use this rule separately without a table in the next example that we're going to look at. At many airports, you are not allowed to take water through a security checkpoint. Suppose that 5% of people accidentally leave a bottle of water in their bags. Also suppose that if there is a bottle of water in the bag, the security screeners will catch it 95% of the time. What is the probability that a randomly chosen person with a bag has a bottle of water in the bag and security finds it? Right, so what we're looking for here, notice that we have our probability of an and, right? So that they find the water and security finds it. Right, we're going to go back to and look at these formulas. Notice that these formulas begin with and we're taking the probability of an event multiplied by the probability of events being given. Right? So we've rearranged these formulas to get these two formulas excuse me, that we see here. Right? So what that's going to mean is if I write out the formula for this one, right? What is the probability that a randomly chosen person with a bag has a bottle of water in the bag? So that's our P of W, and security finds it. Probability that security finds it given that we have water in the bag. All right, so I'm going to make a little note here. Right, the second probability is given that there is a bottle of water in the bag. Because we're focusing just on that group of those people that have a bottle of water in their bag, security finds it. Right, so then we're going to multiply our values that we see here. Probability that someone has accidentally leaves the water in their bag is 5%. So 0.05 times our probability that security finds it given that there's water in there, 0.95. And that's going to give us 0.0475 or 4.75%. So the probability that a randomly chosen person with a bag has a bottle of water in the bag and security finds it, a little less than the probability that they have water in the bag, which is our 5%, and our final answer is 4.75%. Right, so our formulas that we see in 5 and kind of our alternate formulas can be used different ways, and we can also kind of use the table to go back and forth and look at some of those different things as well.